In today's video, I'm going to show you how to do a step load response to tune a power supply. In this case, we're going to be using a module from Linear Technologies. That's the LTM4546Y micro module. And I'll pull up a picture of the schematic and data sheet here for you all. Basically, this is a module that has two DC to DC buck converters that can step voltages down from 12 volts to a lower voltage. That could be 1 volt or 3.3 volts depending on your application. The really great thing about it is it's a power supply, it's commercially available, and it's easy for us to manipulate some of the values to show you what happens when you have a tuned power supply and when your power supply maybe isn't as tuned to load changes as you expect. So what we're going to do is use the SIGLENT SDS2354X-E. That's our electronic load. We're going to be pulling a certain amount of current, and we're going to do a step from one current value to another current value, basically changing the load very, very quickly for the module, the power supply module, and we're going to monitor what the response is from that step load. So we've got an 1168X-E power supply. That's 12 volts at 3 amps for the board itself, and that's coming in on these banana jacks. And then I've got a current probe, this SIGLENT CP4070, that's measuring the current output from that power supply. And I've got an SDS2354X Plus oscilloscope with one of the probes connected up to that feedback loop. So what I'm going to do now is just simply, so we're delivering the power to the supply. I'm just going to turn on the load, and that's going to draw 5 amps. And you can see we've gone up to 5 amps, and we're pulling that current. But now, that's just straight DC. We're just pulling a standard load. But with the SDL, we actually have a dynamic load response. So I'm going to hit Shift and hit Dynamic, and that's going to go over, you'll see the display has changed, and now I'm going from 1 amp to 5 amps load. And I'm going to enable that, and you'll see now I'm stepping from 1 amp to 5 amps, and you'll see that the feedback response on the voltage supply is actually ringing quite a bit. So I'm going to just do a little bit of math here and do some averaging, and I've already set this up. So here's our averaging, and you can see that ringing very, very, very prominent here. I'm just going to expand it a little bit so we can get a better view of what's going on. So current draw, step load. Here we're going, this is actually the falling edge. Let's do the rising edge. Rising edge here. So you can see rising edge 0 to 5 amps, or 1 to 5 amps, and here's our load response. Let's go back to that falling edge. And so you can see both for rising and falling loads. So if we're adding a load to the system and we're removing a load from the circuit, we're seeing a very, very poor response. Because what's happening here, we're getting a lot of ringing. If this switched much more quickly, we may actually have unregulated supply, or at least not very well controlled. So our feedback loop is not quite tuned well enough to provide very good response. So that's part one. This is the detuned side of this particular circuit. What I would like to show you in response to that is what the circuit should look like when it's tuned. I'll also be doing another video in a little bit showing these same step responses only using a Bode plot. Really, step load response is really a brute force way of checking to make sure that the supply that you've designed is going to work properly for the setup that you have. And Bode plot's a little bit more elegant, and it provides you a little bit more information. But you can use both to really optimize your design. So really, this is part one of a two-part video. So if you hold just 1 sec, I'm going to quickly switch this over to the other setup, and we'll be right back. Okay, so I've made those adjustments. Now my power supply, I'm connected up to the tuned section, the other supply on this particular board that has been tuned for step load response. And again, I'm just going to turn on the load and pull 5 amps. You'll see that I have that 5 amps. Now I'm going to go to dynamic, turn on that load, and now you'll see that I have that step response. Let's go to rising edge here. Start where we did before. I have not changed the scaling on the oscilloscope at all. You'll see that we have a much smaller voltage step, and it recovers quite a bit more quickly. I'm going to turn on the math as I had before, and you'll see again I have not changed the vertical scaling on this at all. You'll see a much quicker response, much flatter response, no ringing, and that's where you want your power supply to be for a particular step or a load step. And I also should mention again, with that load step on the SDL, we actually have the ability to control the slew rate for the current. And in this case, we're going as fast as we can, pulling as much current as quickly as we possibly can to really exaggerate what our load response is going to be. And so we're just seeing much better response here. I'm going to switch back over to the falling edge so we can take a look at that as well, and you'll see our averaging here, again, very quickly coming to scale here, and we can bump up that scale if we want to take a closer look at it. But I just wanted to show you a comparison with the exact same vertical scaling, and I'll pull in again another picture of the original untuned example for you to be able to compare those two. So power supplies can be tuned very easily using an electronic load. You can very easily have this set up. It's pretty simple, all basic things that you'd have around your electronics laboratory or design studio. Again, we're using the SDL load, one of our oscilloscopes, current probe, and a power supply. So pretty straightforward. And in the next video, I'm also going to have an application note on this to show you a little bit more detail and talk about each of the parts and some more on the breakdown of the module that we're using.